Hey guys, welcome back. Professor Hank here. So today we're going to be talking about how you can format your console output in C++. Specifically, we're going to talk about these things called I/O manipulators. And the I/O manipulators that we're going to look at are going to be setPrecision. We're going to look at fixed. We're going to look at Showpoint, left, right, and setw. All right, so let's go ahead and begin. All right, so let's learn how this works through examples. Now we'll see how setPrecision works first. Now let's say that I wanted to, create a variable that stores the contents of pi, right? And we'll store it out to a certain level of precision. We'll go out to this many decimal places. And if I wanted to display that on the screen, it would look something like this, okay? You can see we only see 3.14159. Now, why is that? That's because C++ by default will only show you so many digits per field. So this variable contents here, this makes up a field. And so the limit is 6 total digits. Now, if we wanted to change how many digits we are going to see, can we do that? Well, the answer is yes, and that's where setPrecision is going to come in. So to access setPrecision, we have to do #include IO manip, and then that gives us the ability to do something like this. Okay, so we can send setPrecision to C out and say, well, no, we only want to see, one digit there. Okay, and the setPrecision has to come before the field that you're modifying. Okay, so let's see how that changes things. So you can see now we only see the one digit, the one place. Okay, now what if I wanted to see 2? Well, then we'll just change what we put inside the parentheses. And so now you'll see that we see the 3.1. So you can notice 2 things. 1, we just increase the number inside of here. 2, we're moving from left to right, from the furthest left digit. So let's say we wanted to see 3 digits, right? So you just keep on doing this. And you can see now that it grows to 3.14, okay? And you can just keep right on going. So we could do, show us 4 digits, show us 5 digits. And so this behavior of showing us ever increasing number of digits from left to right, from the furthest left digit, this is an example of displaying the contents of the variable or the number from the most significant digit. What's the most significant digit here? It's 3. Okay, and so right now we have a precision of the last number displayed from the most significant digit of 5 digits. Now, what if I wanted to limit to a certain number of decimal places what I wanted to show, right? Let's say I wanted to show 2 decimal places of precision. Well, one way you can do that is to use setPrecision like this, right? You just say, oh, well, I want to show the 3 most significant digits. Okay, and you're like, okay, fine, that shows me 2 decimal places. And you're like, success, right? Problem is that this isn't going to work, right, all the time, most of the time, a good chunk of the time, because it works great if you're counting, or if you remember that you're counting from that most significant digit, right? But what happens if the most significant digit's not 3? What if it's not 3.14 anymore? What if it's 163.14? You have a problem because you only see 163 because it starts counting from the most significant digit. The most significant digit in this example is now 1. It moved to the left. You start the counting from here. So you see the 3 numbers, right? And so you're like, where's my decimal places? Well, if you wanted to see your decimal places, you'd have to change that to 5, right? But you have the same problem, because what then if the numbers to the left of the decimal place change again? What if it becomes, just 63.14159, right? And you still only want to see the 2 decimal places. Well, this isn't going to be a solution for you. So what we have to do then is we have to introduce this fixed manipulator. Okay, so what we do is we put in the fixed and we send that along with setPrecision before the field that we want to modify. So now fixed notation ensures that you have output that has a decimal point, right? That has this format, this decimal format, this decimal notation, this fixed point notation. And then setPrecision changes the way it behaves once you use fixed, and that is that it starts counting as the most significant digit the first decimal place. So now if we change this to 2, then it starts counting 3.14 and ignores everything to the left of the decimal place. when it determines how many digits it's going to show. You're going to get everything to the left of the decimal place, but you're only going to get the first two to the right of the decimal place. Okay, so let's see that. So now you have 3.14. And it doesn't matter how many digits you have to the left of the decimal point, right? You're still going to guarantee that you only see two decimal places. Okay, see how that works? Now, this is an error that students of mine make consistently. They forget about how this behavior works. And so, in our textbook, the first example just shows you how set precision works, like I showed you at the very beginning. And there's a little table in there that shows you exactly kind of what I showed you. But you have to read further to learn how fixed impacts things. And so I think students, I don't know, maybe they don't read that far, they forget that part. So if you want to control how many decimal places that you see, say 4 decimal places of precision, then you have to include this fixed operator as well. Okay, now notice that it does round. So 3.1415 became 3.1416 because, that last decimal place got rounded up. Let me show you that to you one more time, 1416. Okay, so, for programming assignments and stuff that I give my students, say, okay, well, format to 3 decimal places of precision. Okay, this is the correct way to do it, just like this, using fixed and set precision. Okay, so let's go ahead and see how Showpoint works. So I'll create a variable x and I'll assign to it 5. Now, if I don't do any formatting at all, let's say that I just display the contents of x, and even though x is a floating point number, right, we don't see anything afterwards. We don't see like 5.0 or anything like that. Let's say that I wanted to guarantee that I saw a 0.0. Okay, well, that's where the show point will come into play. So I can do show point x, and then I compile and run this, and now you see 5.00000. It fills out the field length with trailing zeros. Now, if you want to limit how many trailing zeros that you see, you can, do that set precision thing. So you could do something like set precision, and I only want to see a total of 2 places. So then you're going to see the first 2 digits because of how set precision works. Now, if you wanted to see a couple of zeros, then you could limit it by having 3 there, right? But of course, then you're stuck again with that same kind of problem. What happens if you end up with more digits than you set precision for, right? Suddenly things look really weird and you end up with this E notation. So the way to avoid that is just use your combination of fixed and set precision instead. And if you do that, then show point becomes irrelevant. Right, so now you can see that you've got your 1505.000. Okay, so show point has its uses, but if you use the fixed and set precision, then show point becomes kind of redundant or irrelevant. Okay, let me show you one more thing about how set precision and fixed works. These are set and forget manipulators, which means that I only have to have one cout statement. I only have to do them one time, right? So I could do something like set precision 2 and fixed. Okay, so in this case, anything that comes after is going to be formatted according to the set precision 2 and fixed. I only have to do it the one time, and it's going to be set until I change it. So I could do something then like cout pi, okay, and then cout x, and then cout 1995, and all of these fields, this field, this field, and this field, are all going to be formatted according to this. You only have to do it the one time until you want to change it, right? So what if I wanted to reset the values? Well, I can set precision back to its default by doing cout set precision 6, and then I can do cout dot unset f, and then inside here I do iOS fixed, and then that turns off the fixed. So now when you go to show your number again, you have that same behavior that you had before we used set precision or fixed. So you can see there's the 8673.14 because the precision was set back and we turned off that fixed point notation. All right, so let's see how left, right, and setw work. So we'll have 2 fields. The first field will contain the string hello, and then the second will contain the number 8675309. So this is the first field, the first thing that we send to cout, And this is the second field, the second thing that we send to cout. So let's take a look at what the output looks like. You can see that they all get mushed together. So the first thing I want to do is I don't want them to be mushed together. So what I'll do is I will change the default width of the field, and the default is 8 characters. Okay, so and that's the minimum. So if you have more than 8 characters, then C++ will automatically expand that field width for you. So as you can see, we see the 1925, the 192586753009, etc. Now I can play around with how wide that field is. So if I do something like this, if I say set w 10, then the field that hello occupies, the amount of characters that are set aside to print out the hello is going to be at least 10 characters long. Okay, so now you'll see the output change. See how all of this space occurred? By default, the value gets printed into the field right justified. So we've got 1, 2, 3, 4, 5 characters in hello, and so we were given 5 spaces worth of padding at the very beginning to fill out the entire field. Now, this is not set and forget like set precision. So set w is not set and forget. So if you want to change the size of the second field, you have to include set w again. So let's make the size of that field 20 characters wide. So now we'll see what that looks like. So you can see hello, the first field, went right out to where the O is. That's 10 characters wide. And then the second field is now 20 characters wide, and it starts right after the O and goes all the way to the end where the 9 is, because again, it's right justified by default. Now, we know how setw works. Now let's see what left does. You can probably guess. Now left has to do with justifying the fields. So where do you start printing the value within the field? By default, it's right justified, but we can change that. We can change it to be left justified. All right, and keep in mind that the manipulators have to go before the field you want to manipulate. So I want hello to be printed in a field that's 10 characters wide, so I have to set w before hello in the cout statement, and I want it to be left justified, so I have to put that below the hello. So let's see how that changes the output. Okay, so now you can see that the printing begins in the left part of the field, and it's still 10 characters wide, but you might also notice that the number here in the second field was also left justified. So left and right are also set and forget. So you only have to set them once, and everything that follows is going to adhere to that setting. So set precision, fixed, show point, left, right are all set and forget. Set w, not. Set w you have to use for every field that you want to change the width for. Okay, so if I want to make the first field left justified and I want to make the second field right justified, well then I'll just tell it. So now this field is going to be subjected to these 2 manipulators. This field is being subjected to these 2 manipulators, right? So that field was handled, and then we want to change things for this field. So the set w and the right are going to impact this field. So you're going to see how that changes things. Okay, so now they're way spread out. So there's the hello, and that its field was padded with the extra 5 spaces, and then there's the number here, and its field was pre-padded, had leading spaces padded in there to fill out its field. And you might be thinking, well, that's interesting. I mean, that's great, but why should I care? Well, let me give you a practical example here. Let's say that I wanted a table of values and I wanted it to look a certain way. So right now, if I had, say wanted to display a table 8.161924, and I wanted to display, 123.456, and then on the next line, I wanted to display 13.9 and 7.245, 3. Okay. This is what it's going to look like if I don't do any additional formatting. So let's see how that looks, right? It just looks like garbage. It's not what I was hoping for at all. Now you might say, okay, well, let's improve things a little bit by putting a space in between the numbers. And you could do that, and it would make a little bit of a difference. So we'll see what that looks like, right? Okay, so, but it's still not pretty, right? What if I want to align everything? What if I want everything to be aligned by decimal places? Well, or if I want there to be more space. Well, maybe then you think, oh, well, I'll just do, a tab escape sequence. We'll see what that looks like. Still not getting us there. It's getting closer because you can see now that at least we've got the columns kind of lined up. If I put in a couple of tab escape sequences in between, it's going to finally give me something that looks like columns. Okay, but see how everything's still left justified? That's not gonna solve my problem for me here. So if we want to have columns that are nice and lined up, and let's say we want to line up the decimal places, well then we can use setw and then go back and use our set precision and fixed manipulators to help us out here. So rather than do this double escape sequence thing here, what we'll do instead is we'll do setw, okay? And that'll give us better control. So we'll make each field, say, 10 characters wide. So we'll put that one there, and we'll put this here. And this is gonna guarantee that each field, each column will be a certain number of characters wide. So now let's see what that looks like. All right, so we're getting closer, but notice the decimal places still aren't lining up. So how are we gonna deal with that? Well, we'll use set precision and fixed to help us out. So we'll do cout, set precision, and let's say 3 decimal places. Just arbitrarily picking that up off the top of my head. Use that fixed point notation. And then you can see everything lines up nice and pretty because we ensured that we had enough characters for each field. And then we used the fixed point notation and we said to 3 decimal places of precision. So now everything lines up nice and pretty. Okay, now that's great, but let me show you another problem that students will run into. So you might have a situation where you have to have a label for your rows, right? So you might have to do something like this. You might have to say, I don't know, I'll just make up a word. This is row 1. And then for this second row, you might do something that looks a little different. So you might say row 2. You're thinking, okay, cool. I have to label everything. And, my professor wanted me to make sure that each row has a label of some kind, or the output has to have a label. And then crap, right? So what went wrong? Why is everything messed up? Everything's messed up because the first field, we added a new field. The first field of each line isn't formatted. So all it's doing is just filling out the field with the value that you want to display. And so they're different lengths. And so those fields are different lengths. So the column of the first fields now is all messed up. So you end up with this jagged table. So how are we going to fix that? Well, we're going to remember to format our first field. So we want to make sure that that field is wide enough to accommodate the value that's going to be put in it. So I think that's what, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's 14. So we'll give it an extra space. So we'll do a field width of 15 for that first column. All right. So now once we do that, we will print it out and you'll see that everything is lined up again as far as the numbers go. Now you take a look at this left side here. It's kind of weird because remember, by default, fields are right justified. Well, if I look at this, what if I want the output to be all along for this first column to be all along the left margin here? Well, then I have to change the justification just for the first field. So I'll make that left justified, and then we'll see what that looks like. We're not going to be done yet, but I'll show you what that looks like. Okay, so now we've got everything fixed for that first column, but now everything's messed up in my other 2 columns. Why? Because I made everything left justified. Remember, these are set and forget. So I need these values in this other 2 fields to go back to being right justified. So how am I going to do that? Well, I'm just going to tell them to be right justified. Okay, so we'll do that. And we will do that. Okay, so this first field is going to be left justified in a field that's 15 characters wide. And then the second field here is going to be right justified, and it's going to be 10 characters long. And then this last field is still going to be right justified. Remember, it's set and forget, and it's going to be 10 characters wide as well. And similarly for the second row. So now if run this, it's going to look exactly as I needed it to look. So now you know how to use IO manipulators to format your output in C++ and how to create nice looking tables. Thanks for watching. We'll see you next time.